I'd like to show you a few examples of finding surface areas of different types of three-dimensional solids. The first one I'm going to take a look at here, this is technically a rectangular prism. Okay, remember, a prism has two congruent bases on the top and the bottom, and then you have straight edges connecting those. You have rectangular sides. You really don't know which is the base and which are the sides. So for a rectangular prism, I would just assume that whatever's at the bottom, that's what we're going to treat as the base, because you could turn it different ways and you could actually have different bases. But anyway, in this particular case, I'm going to treat this bottom part as the base here. All right, there are two different types of surface areas. When you're talking about a surface area, first of all, what you're really talking about is finding the area of the surfaces, okay? In other words, if I was going to paint the outside of the shape, how many square units of paint would I need to be able to cover the surface, all right? Or if I was going to wrap it in wrapping paper, how many square units of paper would I need to wrap the entire thing in paper? So in a sense, we're really not doing that much in 3 dimensions other than just looking at the original shape. And in fact, you can imagine kind of flattening the shape out. So for example, this shape here, we've got a 3x4 rectangle that goes across here. You've got a flap that's a 2x4 up here. Okay, imagine that this was a cardboard box and you kind of flatten the cardboard box. We have a 2x4. So this length is 3, this length is 4. This length here would be 2, matching up with that, and of course that length's still 4. The base of this box would kind of go like that. And then you have the flaps on the sides as well. So you have a 3x2 flap on the side that kind of fits off like that. You have a 3x2 flap on the side that kind of fits off on that side. And then the back, you know, this piece here would wrap around to a back piece that's also a 3x4. So you'd have another 3x4 that looks something like that. Anyway, the point is, if you took the box and you flattened it out, it's really a bunch of rectangles. And by the way, this flattened version of the shape is referred to as a net. Okay, if you just flatten the box out and you look at each of the 6 faces separately, it's referred to as a net. So what we're really doing when we find the surface areas, we're finding the areas of each of the rectangles that make up the shape. Now, I don't think it's a really good use of your time to try to draw the net every time, and it's probably more effort than is necessary. Here's how I do this. I look at each of the individual faces separately, okay, when I'm trying to find the surface area. And I just remind myself, this is a rectangular prism. I'm just finding areas of rectangles. I just want to know what the total area of all of those rectangles that make up this shape is, okay? So the biggest thing is you need to be kind of organized to make sure that you get all of the rectangles, that you get the correct dimensions, and that you don't leave out any sides or repeat any sides that weren't supposed to be repeated. That's really the big thing. So a lot of times when I do these problems, I will really treat them as 2-dimensional problems, and I draw the individual faces and the labelings, and then these are just very basic area problems, and I think that can make life a lot easier. All right. Now before we do this, you'll notice here, this is asking me to find lateral area and total area, or sometimes this will just be called the surface area, okay? Lateral area is just the area of the sides, okay? So we're looking at this 2x4 and this 2x4 up here as the bases. So this face, this front face, this side face, and the back face, those would be the lateral faces, okay? Just the areas of the sides, okay? So I'm gonna list those out, okay? I have a 2x3 rectangle here, and I'm going to draw it looking like a 2x3 rectangle. And I actually have 2 of these, because I've got one on this side and I've got one on this side, okay? So you don't necessarily need to draw both, but I'm going to draw both here just for the time being. We have a front face here, and we have that same face also in the back. That face is a 3x4, okay? So we've got a 3x4 face, and we've got this other 3x4 face, all right? So for the lateral surface area, we're just adding up the areas of each of these faces. So this area of this face is a 2x3, that area is 6. That area of that face is a 2x3, that's 6. The area of this is a, the front face here is a 3x4, its area is 12, and in that back face there, its area is 12, okay? So for the lateral area, I'm going to add 6 plus 6 plus 12 plus 12. Let's see, that's 24 plus another, that looks like 36, okay? This is area, okay? This is just saying if I gridded off the outside surfaces, how many squares would cover the outside surface. So you would say 36 square units or 36 units squared if you want to write it that way, since I didn't specify centimeters or feet or anything like that, okay? Now the total area, we got these 4 faces, but the total surface area is also going to add the base faces, okay? So for the base faces, we have a 2x4 base, and we have a second 2x4 base, okay? Each of them will have an area of 8, okay? 8 and 8 is 16, so I'll add an additional 16 to that 36, and that will take me to a total that's 36 plus 8 plus 8. 36 and 8 is 44, plus another 8 is 52 square units. So be careful. If they just say find the surface area, you're adding up the areas of all the faces. If they ask you to find the lateral area, it's just the areas of the faces that make up the sides, all right? But that's the basic concept, okay? For prisms, it can be really simple, okay? It can be a little bit more complicated if you're dealing with other types of shapes, but hopefully not too bad. And again, you can really simplify it on yourself by drawing faces. And by the way, you know, you don't need to draw this face twice. If you just want to say, hey, I have an area of 6 and there are 2 of them, that's 12. I have an area of 12, there are 2 of them and that's 24, and I have an area of 8 and there are 2 of those and that's 16. You know, that's also okay. But that's the kind of thing that I think can make these problems work out relatively nicely.